I'm Steve Aichele. I'm the user engagement focus area lead for hydrography, and I'll be talking about some of the infrastructure we've been building for updating the NHD with elevation data, ably assisted by Amanda Lowe from our NG Talk. So for those of you that have been tuning into this community call for the last 8 or 10 years, you know we've been talking about elevation-derived hydrography, previously LE Hydro, for quite a long time. This goes back to probably about 2010 or so, maybe even a little before that. Jeff Simley was an initial advocate for it. On the last few years, we've been really trying to build the structures and find some of the pitfalls associated with trying to standardize those acquisitions to leverage our 3-depth data. And we've been fortunate in that we have had a steady funding stream associated with Mapping Alaska that we've been able to leverage to do some of that developmental work. It's also a real benefit for Alaska. For many years, Mapping Alaska was kind of a second thought, an afterthought. And they had some of the worst elevation and hydrography data anywhere in the country up until we started remapping them about 10 years ago. But with the completion of IfSAR up there, and some of the governance structures we've been able to build through the Alaska Mapping Executive Committee and the Alaska Mapping Program, we've been able to launch this elevation-derived hydrography update process in Alaska. And I think the experiment has been very educational, and we're building the basis to launch this program in CONUS going forward. Hopefully I don't have to elaborate too much on the National Hydrography Datasets, but these datasets, even in their current form, provide a lot of benefits. Estimated about $538 million in annual benefits, largely through cost savings to state and local governments. And this is back in 2016 when we did the HRBS. An updated modernized 3D hydrography program that actually aligned with the 3-depth data could actually provide up to over $1 billion a year in annual benefits to users, depending on exactly how that program's configured. And that's some of what Becky's been working on in the program plan and call to action that she's talked about a couple times. So many of you are engaged in our current data management approach, and it's been very much a collaborative effort, working with Joel Scallett and the partnership support section, NG Talk. We've had stewards and data editors across the country updating what has been based on the 1 to 24,000 scale line work. In a lot of places that's been improved. A lot of places, some errors in that data have been fixed. And it currently includes almost 8.5 million miles of stream network, and 130,000 nested hydrologic units, the HUCs and WBD. And I think maybe the most important thing that local stewardship brings to the table is knowledge about how some of these local systems work. They're particularly in some of the lowland areas. You can look at that in an air photo or an elevation model or LiDAR point cloud, and it's just not at all clear what's going on in that environment. You really need to have some idea how that local hydrology works and what's going on the ground to be able to make meaningful edits or updates to that data. Unfortunately, one of the drawbacks of this stewardship program is that really the updates aren't very uniform. In some places, this data has been updated regularly, and some places have been done very well. In some places, that 24K data hasn't really been touched, which means that 24K data is largely the same blue line data that was collected when we surveyed those maps, maybe back in the 60s and 70s. And so there's some real questions about the quality of the data, the variable data quality across the database. And much of that older data doesn't align at all well with this shiny new 3-depth elevation data. And really, at this point in time, people expect those data sets to align and interact and cooperate so that you can do good watershed models really leverage those data sets against each other for benefit. And so where we're going with this is to use that 3DEP data as a source to create the hydrography data. And this, in some ways, goes back to where we were over 100 years ago, right? We're compiling the maps together into a 24K source, into a 24K product. But the goal is to standardize these so that they align vertically, horizontally, and temporally. So the same source data as the 3DEP, and really leverage them for applications. The HRBS, documented some of the widespread need for this integration. Is certainly one of the most persistent complaints, particularly from the modeling community that try to use elevation data to inform some of our 2D hydrography at this moment. And then really where I think we're going with this is towards a stewardship model that relies less on stewards for sort of bulk editing and wiggling the lines, but rather looks for that local knowledge and information about how those the changes to the geometry through a lighter weight client like the markup tool. So we've been grateful for the labor that many of the stewards have provided over the years to update the data set. But really, that's not necessarily the best use of your expertise. We're trying to move towards a system where we're really looking for that local knowledge rather than sort of local labor. Again, those of you that have been tuning into this program for a while know we've been at this off and on for quite a while. And some of these names are blasts from the past for you. GeoNet and BotHat, ArcHydro is out there. There are a lot of different techniques out there to derive hydrography from elevation, but despite each of them having strengths and weaknesses, none of them was really the magic bullet they were looking for that got this thing done right. Each of them required some significant manual editing when they were done, and so rather than try to prescribe an approach or a toolkit for creating this data, we took a step back and decided that really what we want to define is the product, and then verify that we're getting that product into the data set such that we have a standard quality in the hydrography data that we're providing. But that way people are flexible to use methods that suit their terrain more appropriately. To try to figure out what this world was we're getting into. In 2016, we launched a few very small pilot projects, so 5 separate Huck 10s scattered across the country. There's two in Colorado, 1 in the mountains, 1 in the flats, 2 on the Delmarva Peninsula, so both pretty flat, but 1 coastal, 1 inland, and then 1 on the edge of the Appalachian Mountains, so a little bit of eastern humid topography there. And what we were tending to find out primarily was how much it might cost to launch a nationwide program. And so we ran these 5 Hucks through 2 different contractors and compared results on both the data and the labor involved. But also we wanted to get a sense of the technical issues that would need to be resolved before launching something like this. Oddly enough, the costing side of the thing came out relatively smoothly, but we had a long list of technical issues that we needed to get under control before we could move further on this exercise. Maybe one of the first and biggest issues was just an understanding of the NHD and the NHD data model. Those of you that have been around it for a while know it is fairly complex, but many of you also probably regard it as a friend. The expanding the circle of people that really understand that data set, data model, to include contractors and technicians in contractors' shops, has been a learning curve, and it's something that we've needed to sort of ramp up gradually to get that moving. In a similar sort of way, we hadn't contracted for hydrography data before. And so we needed a whole new set of documents to support that, so that we were communicating effectively with the contractors. They were understanding what we were saying. It's not something that and it's just necessarily think a lot about from from the geographer side of the picture. But if you're looking at launching a nationwide program similar to 3DEP, you need to get that kind of thing under control. Um, and then looking at this idea of defining a product rather than defining a process, we needed to have some pretty good standards and methods in place to test those standards and confirm that the data we were receiving, met our specs. And again, that's not something we had done a lot of in the past. We have, largely relied on expert editors, on local knowledge to confirm that that the data we were getting was good. Um, so we didn't have nearly the same kind of rigor to our data checks in hydrography that we have in elevation or formerly in orthoimagery. So putting that all together and building that process to move from kind of a boutique environment to a production environment actually was a fair amount of work. We made a lot of progress on that, and we're going to show you some of that progress. But we're also going to talk a little bit about sort of our next wave of testing, how we were doing on those things. So that was 2016 with those first 5 pilots where we said, "Whoa, we need to do some work on this." So we did go back, we did some work, we tried to pull together some standardized, some specifications and standards, um, task order language, various other sorts of supporting documents, and managed to put that together. And again, we had an opportunity in Alaska because of a funding stream to test these. So we took the Kobuk River Basin, which is that tiny little blue spot in Alaska up in the northeast, but the upper right of your frame. That little blue spot, by the way, is about the size of Connecticut. But we took that space and divided that up into among 3 different contractors to figure out, how these sort of second generation documents and specifications and task order language and so forth were working. And those projects have actually mostly been completed now. All the elevation-derived hydrography has been accepted. We are still sort of working back and forth a little bit on some of the WBD up there. And then similarly in 2020, we had an opportunity because of a special initiative to have a project in Southeast Texas where we tested some of these things in a CONUS environment. Um, I would say that one of the challenges, we maybe couldn't have picked a more challenging environment to work in CONUS because it is, down there, it is awfully flat, awfully wet, and in many parts of it are very urbanized. There's a lot of interesting stuff going on with the water system down there. Uh, Curious to, well, we're still working out a little bit how that's all going to play out. So again, we mentioned that Alaska is really an ideal place to start. And that was because of the completion of IfSAR. We wanted, the sort of the next thing on the agenda once we had good elevation across Alaska was to move to deriving things from elevation, interpreting that elevation, and pulling that hydrography data was the place to go. Obviously, it's the difference between working in even a 5-meter IfSAR environment as compared to the 10 or 30-meter DEM contour-derived DEM environment that we had been in is dramatic. You see different features on the glacier here. That's a level of detail that was almost pretty much unimaginable working from a contour map source. I guess I'll also mention that we're only going to talk about a little piece of this whole sorted workflow here to get from initial contracting up in the upper left over to those distributed products in the cloud. This is really just about fixing about tidying up the line work and bringing that into the NHD and WBD. There's still a whole other set of processes in place to make the NHD into the NHD plus high res and do some various other tasks in here. Actually, a lot of what we're going to talk about today is that even just in those 3 purple boxes, looking at EDH production and EDH inspection. And then, so the other item that we'll talk, sort of laying out some of the things we'll talk about here, are some internal processes to talk about how to talk about, you know, the back end for maintaining this data, right? It's one thing to um, talk about getting hydrography data from elevation. There's a whole set of technical issues there, obviously. But there's also just a whole bunch of data management and contracting issues that we've fortunately been able to work through with the Alaska projects to the point where we're maybe not quite fully operational, but we're getting pretty close on having a standard template for the task orders, having the contracting office and the contractors speaking the same language, having contractors understand our expectations in inspection, and having our inspection processes, you know, standardized and routine rather than kind of developmental where they were a couple of years ago. And then really the sort of last stage of this process is coming up with some funding mechanisms. And this is, again, a fortunate place where the Alaska projects are able to provide that infrastructure to build the Alaska work. So the first stop here, the initiation of the project is really building the task order language. Back when we did those 2016 projects, Ellen Finelli and I sort of sat down for an afternoon and went from the old cartographic standards for 24K data and tried to come up with what that task order should look like. And we didn't do a very good job of it, actually. There's a lot of uncertainty, a lot of vague stuff in the task order, a lot of things that we knew what we were talking about, but the people we were passing the task to didn't understand the words we were using because, you know, the NHD had been kind of a closed environment for so long. So we had to go back and, you know, rearrange that and work back and forth in several different levels to try to figure out, you know, an appropriate way of communicating these expectations to contractors. And that involved a whole set of supporting documentation as well, you know, so data templates and schemas so that everybody's communicating with a standard set of, you know, data fields and so forth. Extensive contractor questions and responses to the first batch of task orders. One of the things that we hadn't really considered, but, you know, retrospectively looks obvious, is that we really do need drainage density targets, particularly in Alaska where there isn't a lot of control. You know, you can map every low spot in the ground, but many of those don't have water in them. Coming up with some kind of, you know, prediction about how many of those features should be drawn as part of the NHD to make it useful and functional was an important piece of this. And then we've had an iterative set of updates to the specifications. We have a lot of challenges with scheduling because we don't have a fully built production operation in NGTOC to inspect these things. So we're sort of building that as we contract new data, and then building a system to manage the communications and records back and forth between the USGS and the contractors. So I think with that, I'm going to pass it over to Amanda to talk details rather than sort of glittering generalities.
Okay, thanks, Steve.
Sure.
Yeah, I am going to get into a little bit more detail, and specifically, I'm going to talk a little bit about specifications, and then I'll talk a little bit about data management. So what do we do with the data once we receive it from the contractor? And I'll talk a little bit again about our inspection process and just some of the communication that we've had back and forth with our contractors trying to ensure that the data set meet the requirements of the program. So first, I'll talk about specifications, and for our initial set of task orders, so the pilot project Steve referenced for the Kobuk area in Alaska, these were task orders that were developed in FY19 for these pilot projects, and they were prior to the publication of any USGS specifications. So as a result, these task orders referenced alternative documents containing requirements for the collection of hydrographic features derived from IfSAR elevation data. So these two documents were the Alaska Hydro Data Editing Standards, and then also a draft version of the Alaska NHD specifications. So this included many of the requirements from the upcoming EDH specifications to be published. Okay, so in July of 2020, to support the objective of obtaining EDH that will be used to update and enhance the NHD, the USGS has published the EDH acquisition specifications and the representation, extraction, attribution, and delineation rules, also known as the READ rules. And hopefully you were able to attend the session of this communications call where Christiane Archuleta and Sylvia Terziati presented on these two documents. And basically they provide requirements and guidelines for developing elevation-derived hydrography. So all EDH task orders developed in 2020 and later reference these two publications. And this is true for both Alaska as well as CONUS. So as we worked through delivery of these initial data sets, as we did the inspections on those and gave feedback to the contractors, especially for the 2019 pilot projects, we responded to inquiries regarding specification interpretation from contractors in the form of guidance papers. So these are intended as aids to clarify existing requirements in the EDH specifications and READ rules. And there are two basic categories of these guidance papers that we've issued so far. So they include those that describe our inspection process and also those that clarify data collection scenarios. These documents have been issued directly to contractors with existing task orders only to this point. We're also in the process of preparing them for access through our standards website for public access. Okay, so as far as data management goes, once we receive data at NGTalk for inspection, we first receive the data from the contractors. This is usually done via FTP. The data sets are small enough at this point that we can do that. And so we're notified through our commercial partnerships team that the data are ready to download. And the commercial partnership is the group responsible for managing all task orders under the Geospatial Products and Services contract, or GIPSY. Next, we distribute the data to our research and data validation teams on our internal network. And these teams work together to inspect the data and compile feedback for the contractors using an inspection process developed to ensure adherence to the specifications. Okay, so for Alaska, EDH data are delivered to the USGS by HUC-8s, and part of this inspection process is performed at that level, and I'll talk more about what that involves. And then the data are further divided into HUC-10 groupings for further review. So Alaska EDH deliveries consist of 3 components, and EDH deliveries for CONUS for that matter. So part A is delivery of elevation-derived hydrography in the schema defined in the specification. And the validation of this data set is performed by a dedicated EDH team, many of whom I see are on the call today. And this is a team that was newly formed at NGTalk, and we are still building it by hiring and training new members. Part B is conflation to the NHD, and it's managed by our geoconflation specialists in our partner support section. And then finally, part C is making updates to the Watershed Boundary Dataset, and the validation of this dataset is performed by the WBD team. So the remainder of this presentation focuses mainly on the part A part of that inspection process. Okay, so initial deliveries of the Alaska EDH from the 2019 pilot projects were used to further develop and refine inspection methods intended for contract deliverables. So this image depicts the NHD in a small area of the Kova River region prior to EDH updates. And then the next slide, so it comes up here. There it is. Okay, so this image depicts the EDH data delivered for the same area. And as expected, the density of features has increased significantly. So our initial inspections of data delivered for the pilot areas aim to perform a manual visual review of 100% of the delivered features. And as you can imagine, we quickly realized this was not feasible given the resources available and contractual deadlines for inspections. So we instead turned our focus to ensuring our automated tools are giving us the most accurate results possible and to developing sampling methods for manual review. So the pre-screening of EDH data, as I mentioned earlier, this is automated checks, and these are checks done at the HUC 8 level, and this is performed using a suite of automated tools and processes. So these include looking at drainage density by HUC 12 based on guidance issued with the task order. Artificial paths, are they inside, or artificial paths outside or streams inside polygons? We're also looking at monotonicity, looking at vertex spacing. So vertices must be no closer than 1.5 meters from another vertex. Vertical placement above and below ground. So no vertex Z values should be above the DTM surface, and no vertex Z values should be more than 2 meters below the DTM surface. And that's specific to Alaska. Horizontal placement, XYZ coordinates of intersections and water body vertices relative to hydroflattened surfaces, topology, and the geometric network. So the results of all these pre-screening processes are used to determine whether the data set should proceed to manual inspection. So once the data are approved for manual inspection, the HUC 8 deliverable is subdivided into groups of HUC 10 areas. And these groups are assigned to inspectors for review. And within each area, some features will have a 100% inspection and some will have a sample inspected. So those features that will have 100% inspection done are subsurface connection features, so underground conduits, connectors, and culverts. Also glaciers and features with new capture conditions, so areas of complex channels and coastlines. And then the features that we're taking a sample of include streams, drainage ways, artificial paths, lake ponds, reservoirs, and double line streams. So the way we're sampling these is by a stratified random sample, and the weighted error is based on NLCD classes, slope, geomorphic index, d-infinity flow path, geomorphons, plane curvature, and we're reassessing how these samples need to be done based on terrain and based on all these different things and how the area we're looking at is different from those that we've inspected in the past. So during the manual inspection, the review team is looking for potential errors in 3 different categories. So they're looking for completeness, so errors of omission or commission. They're looking at integrity, so they're looking at the schema and codes used. They're also looking at hydrography types. And then they're looking at placement, so both horizontal and vertical placement. So this image gives an example of some horizontal placement errors that a reviewer might encounter during their inspection. So once the full inspection is complete, the errors are compiled from both pre-screening and manual inspections. And manual inspection errors are flagged spatially and categorized by error type, and then we write a summary report. And so if the number of errors exceeds the thresholds set for a given category, then we request corrections. So we provide this feedback to the contractor and ask them to provide back a set of corrections. So also, this has become a central part to developing processes and developing these data sets in coordination with our commercial partnership team. So like I already mentioned, we're issuing formal inspection feedback to contractors, and we're also having monthly meetings as per the task order if those are required. We also have ad hoc technical discussions or, via email. Sometimes they'll send in questions for us. And then one other thing that we've added recently is bi-monthly technical exchange meetings with all gypsy contractors who have current EDH task orders. So these are alternating months with EDH and 3DEP. And so this gives us a forum to discuss any guidance that we would need to issue, any kind of clarification or description of our inspection process that we would need to have with our contractors. So this has been a good addition. We've only had one of those so far, but we think that this will really help us to improve that communication with our contractor groups. So I think with that, I think there's one more slide for Steve.
All right, so the idea here is to really, where do we go next? That's a question, that's what we've been trying to lay out in the 3D National Terrain Model Call to Action, part 1. It's the 3D hydrography program. So again, this, as this sort of implies, there might be other 3DEP derivatives in the pipeline, but first we're going to focus on building a hydrography network to leverage that 3DEP elevation data. That plan was sort of, the first draft was completed, I think, at the end of April, and is out for review in a variety of places at the moment. We're looking for feedback by the end of August, and should have that out fully published by the end of the calendar year. And at that point, really the question is to go from there to building a full program. We think we have the sort of the back end, the plan, the processes in place. Really what we would need, is the funding, much like with 3DEP in the early years. So this is really, it's an evolution, but it's also in many ways a clean break. We've learned a lot mapping hydrography over the last 20 odd years with, everything from RF3 and 100K NHD and NHD plus and NHD high res and high res NHD plus. And some, we're learning from that, but really, I think this outlines in some ways a new beginning for uh, a really, again, a really 3D hydrography activity that is conscious of and works in coordination and complement to the elevation data. So really the keys there are, again, to move to an operational posture in terms of deriving hydrography from the elevation data, and shifting in a lot of ways from kind of a cartographic data set that did some GIS and modeling things, which is largely what the NHD has been, into a better accounting of the entire hydrologic cycle. Trying to provide connections to engineered hydrologic systems like we've seen in the DC pilot projects, trying to provide some better understanding of groundwater surface water interactions, and provide something other than just overlap with the NWI. Really provide sort of high tempo communications with NWI, trying to understand how to build linkages between both data sets, so that they don't have to, there's nothing redundant, but that those two data sets would work in complement as well. And then again, we've heard about the National Hydrography infrastructure a number of times on this call, but really fully implement that vision of the 3D HP as something akin to the road network, as a set of addressing and routing and indexing tools that position hydrologic features or hydrologic events, hydrologic activities, in space and relative to each other. That's, we played with that from time to time, but really building that out as a functional operation is kind of the final end goal of the 3D HP. And I think as we roll out this plan, you'll hear a lot more about it in the next several months. And I think with that, that's the program. And so with that, do we have any questions out there in the crowd?
Yeah, hi, Steve. This is Yvonne Allen. So there's are a whole lot of, obviously, I think that Alaska is a great place to start with working out some of these task order related issues, because the collection of the LiDAR is perhaps a little more standardized. But as we get into CONUS, it seems like we run into problems with acquisition or environmental conditions at the time of acquisition. And I was wondering how those problems that are inherent in the LiDAR, how are those uncertainties and problems propagated into the EDH?
Well, they're probably two different directions on that. One is, if in the areas of very low relief that you're probably thinking of, if something's flooded, it's at the time of collection, it's flooded, and there isn't, I mean, frankly, isn't a whole lot we can do with LiDAR to sort that out. When we do have ambiguities in the elevation surface, we do allow imagery or other complementary data sources to be used. But all our inspection processes are based on matching the hydrography to the elevation. So this is something we run into a fair amount in Alaska, where a stream will come out of an upland into an alluvial plain next to a river and just kind of disappear, at least from an elevation standpoint. In those instances, we do use imagery rather, to sort of inform that elevation, inform that channel shape. But then we compare that channel shape to the elevation data to make sure we're staying below the land surface and maintaining monotonicity. I mean, the other thing that does come through this, that working in a network and knowing that there's something upstream and something downstream rather than sort of a more pure remote sensing context, is that you do have that kind of hint that there should be a feature there. There's some amount of information that comes about just by knowing what's upstream and what's downstream. There should probably be some way to connect those things.
Could I add on to that, Steve? I just had a couple other. So I think in order to fully understand the uncertainty of the elevation-derived hydrography, you first have to fully understand the uncertainty of the elevation data. So one of the research tasks that we've been working on the past year and will continue on into next year is developing uncertainty rasters for the 3D elevation program. And basically what those are meant to do are to describe different sources of uncertainty and how you can be more or less sure about the elevation data values, and based on a number of different criteria like interpolation. I guess environmental conditions could be incorporated into that, slope, all of these different things. But understanding the uncertainty of the elevation data is the first thing, I think, from my perspective.
Thanks. That makes me really excited to hear. I'm really glad you said that. Thank you, Amanda.
That's great. We're very fortunate to have been able to bring Amanda over to the hydro side. She spent a long time in elevation inspection. We've really capitalized on some of her experience there to help build these processes for hydrography. I see a question about the vertical accuracy needs differences, and those do vary. I think Amanda mentioned, so 2 meters in Alaska has been our starting point. Although we are doing some work on the North Slope at the moment, where 2 meters probably is a little bit too loose. I think we started with 1 meter for the Southeast Texas project, and found that was probably a little bit loose as well. So this is something I think we'll probably refine as we get a better sense of different terrains and sort of the expectations in those different environments. Who else do we have here?
Steve, we've got a hand
Yeah.
raised up by Jane. Jane, do you want to unmute yourself?
Hi, yeah, this is Jane from California.
Yes.
Wondering how much of this, I mean, I'm all for public-private partnerships, but how much of the workflow information is going to remain proprietary? How are you dealing with that?
Several of the contracts we work with have been doing presentations. I think a couple of them actually presented on this venue. But in other contexts and publishing papers describing the process, perhaps not in perfect detail, but in sufficient detail that you understand the workflow. We also do have the opportunity to, and much like we work with our LiDAR vendors, we do have the opportunity to go really get a better, much more detailed understanding of their process. But those are typically, we typically have some disclosure restrictions on that. I don't know, I guess, does that sort of get where you're going with that, Jane?
Yeah, as a steward, we may or may not choose to work with, one of the contractors that are already
Sure.
in the process, and so just figuring out how to figure out our own best practices along the way.
Sure. I suspect this is going to be a learning process for all of us really as we try to stand up a program.
Yeah, thank you.
Sure. And it's Ellen Fairs had her hand up as well.
Hey, Steve, this is Ellen from Pennsylvania.
Yep. Hi there.
Hi. I kind of perked up when I saw one of your slides that mentioned the geoconflation team because a theme I've kind of seen repeated in some of the USGS papers, particularly the ones by Sylvia and Christy, was the idea of conflation.
Mhm.
And there's kind of a through line of treating EDH as features that will have equivalencies. But I haven't been able to find information online about how these equivalencies are determined. And I took the NHD training, and they said that conflation was beyond the scope of the training. So I was wondering if you either knew a place online that would have resources for proposed NHD conflation, or if you could share the contact info for somebody from the geoconflation team.
You betcha. There's a fellow, he was on the call earlier today, David Anderson. I don't know if he's still on or not. I can't see the list here, but he knows more about geoconflation.
I'm still here.
There he is. He knows more about geoconflation than any other living human being. So he will gladly talk to you at length about geoconflation.
Okay, thank you so
I think
much.
there might have been a little bit of a misunderstanding of that NHD class. There is a separate geoconflation training. So
Oh no.
that might
Okay,
be why
okay.
that was beyond the scope of that class you took.
Okay, okay. Well, thank you for clarifying.
Sure enough. And David, again, will gladly help you with conflation. Other questions?
There is a question from Francis. It says, where can we obtain the draft Alaska EDH specifications document?
The draft doc, so this is from the 2019 projects. I suppose you just send me an email and I can provide that to you. That because that was kind of just an artifact of those particular task orders, that wasn't really a published document. Other questions? No, there's a question from George in DC. Yep. And he's absolutely right. He has a fair amount of he knows quite a lot about the complexities of urban systems. George is our partner in the DC Metro Hydro project. And that is definitely an area that we're still working on. As many complexities as there are in LiDAR and IfSAR and deriving those things from elevation data, there are quite possibly more variables in the engineered systems, not the least of which is record keeping on those engineered systems. DC had pretty good records of their plumbing. Many other cities don't have such great records of their plumbing. And at some level, we also need to figure out programmatically what our mission is in terms of representing those connections. And DC is a great example because it does include both highly detailed connections of how individual catch basins and grates in the road connect to individual outfalls, but we've generalized that somewhat to include in the NHD. That was the first shot at it. It's something we need to work on going forward. But you're absolutely right, George. There are a lot of complexities in urban systems. And then how are you getting culvert data? The culvert data is coming from the elevation data, and there are different processes that the different contractors use to identify those culverts. But at some level, it's a matter of looking for where the water ponds and seeing if there's a road holding it back. Other questions? Okay, well, it seems like the chats and the questions have tapered off, so we'll call it a day. Thanks, you've been a great audience, and tune in next month for another installment of the Hydrography Community Call. All right, thanks a lot.